Biomed Cafe menu, Intermediate Filament or IF will be presented today. We will talk about IF discovery, IF structure, IF function, and quiz game. I'm Dr. Biomed, cellular and molecular biologist. Welcome to the Biomed Cafe channel. In this channel, complex biological and medical contents are presented in a simple, classified, and summarized form. IF discovery, they saw something others didn't see. William Astbury in the 1913 used her in its non-estrous and estrous form and showed that such extended, stable, and flexible rods are made from highly ordered proteins. In 1968, Howard Holzer discovered intermediate filament as a further independent filament system in cells obtained from chicken muscle. Cytoskeleton. The cytoskeleton is a network of filaments and tubules. It extends throughout the cell to the cytoplasm. It's located in all cells. It plays a role in giving shape to the cell, especially in cells without cell walls such as animal cells, in movement of cell and organelles, in organizing of cell, and in keeping the cell's organelles in their place. Cytoskeleton can be divided into three groups: microtubules, microfilaments, and intermediate filaments. Intermediate filament characteristics. Intermediate filaments are stable and stretchable. They can be extended manifold their initial length. Their diameter is about 10 nanometers. Intermediate because their average diameter, 10 nanometers, is between microfilaments, 7 nanometers, and microtubules, 25 nanometers. They are not found in all eukaryotes and are absent in fungi and plants. Intermediate filaments extend throughout the cytoplasm and inner nuclear membrane. Now I want to compare intermediate filaments with microfilaments and microtubules. 1. Intermediate filaments diameter is 10 nanometers, but microfilaments diameter is 7 nanometers and microtubule diameter is 25 nanometers. 2. Intermediate filaments do not have a binding site for the nucleoside triphosphate, but microtubules and microfilaments have it. 3. Intermediate filaments lack polarity. It means they do not have a minus end and a plus end, but microfilaments and microtubules have polarity. 4. Cytoplasmic intermediate filaments do not undergo treadmilling, but microfilaments and microtubules undergo treadmilling. 5. Intermediate filaments cannot assemble and disassemble quickly, but microfilaments and microtubules can assemble and disassemble quickly. And finally, intermediate filaments are different in different cells, but microtubules and microfilaments are almost the same in different cells. Intermediate filament structure. An intermediate filament is comprised of two antiparallel helices. It may be composed of any of number of different proteins. IF assembly. IF proteins. Folding of IF proteins into a conserved alpha helical monomer. Alpha helical monomer. Two alpha helical monomers align next to another, forming a coil called dimer. Then two dimers align next to another, forming a protofilament or tetramer. Two tetramers align next to another, forming a sheet of 8 tetramers. Finally, 8 protofilament or sheet of 8 tetramers link end on end to neighbors by a staggered overlap, forming the intermediate filament or supercoiled sheet. Intermediate filaments can be divided into 6 types: Type 1, Type 2, Type 3, Type 4, Type 5, and Type 6. Types 1 and 2 of intermediate filaments types. Type 1 is acidic keratins and Type 2 is basic keratins. They're made of keratin, and they are the most diverse among intermediate filaments. They can be divided into 2 subgroups: epithelial keratins and trichosthetic keratins or hair keratins. Epithelial keratins are located in epithelial cells. Trichosthetic keratins or hair keratins are located in hair, in nails, in horns, and in reptilian scales. Type 3. It can be divided into 4 subgroups. The first subgroup is desmin. It's a structural component of sarcomers. It's located in muscle cells. It plays a role in connecting cell organelles like the desmosomes with the cytoskeleton, in a structural and mechanical support of muscle cells, and in maintaining the structural and mechanical integrity of the contractile apparatus of the muscle tissues. The second subgroup is glial fibrillary acidic proteins or GFAP. It's located in astrocytes and in glial cells. The second subgroup is periphery. It's located in peripheral neurons and vimentin. It's located in fibroblasts, in leukocytes, and in endothelial cells. It plays a role in supporting the cellular membranes, in keeping some organelles in a fixed place within the cytoplasm, and in transmitting membrane receptor signals to the nucleus. Type 4. Type 4 is neurofilaments. It's located in neural cells. It can be divided into alpha-internexin, neurofilaments, cinnamon, and syncoilin. Type 5. Type 5 is nuclear lamins. They're made of lamins of fibrous proteins. It plays a role in having a structural function in the cell nucleus and in giving a structural support to the nuclear envelope. Type 5 can be divided into 2 subgroups: the nuclear lamina and lamina. The nuclear lamina. They are located in subjacent to the inner surface of the nuclear envelope. They can be divided into 3 subgroups: lamin A, lamin B, and lamin C. Lamina. They are located throughout the nucleoplasm in the nucleoplasmic veil. Type 6. Type 6 can be divided into flencin, facinin, and nescin. Intermediate filament functions. 1. Cell junction. Some intermediate filaments interact with desmosomes, cell-to-cell adhesion, and hemidesmosomes, cell matrix adhesion. 2. Anchoring organelles. Intermediate filaments anchor and keep some organelles in a fixed place within the cytoplasm. 3. Protection against tension and stresses. Intermediate filaments in epithelial cells provide protection against different mechanical, metabolic, oxidative stresses and enhance its resistance to compression, twisting, stretching, and bending. 4. Prevent onset of apoptosis. Intermediate filaments strengthen epithelial cells and may prevent onset of apoptosis by reducing the probability of stress. 5. Support system or scaffolding of nucleus. Intermediate filaments serve as structural components of the nuclear lamina. 6. Maintaining the structure of the cell. Intermediate filaments together with microfilaments and microtubules form the cytoskeleton and maintaining the structure of the cell. Proteins associated with intermediate filament. Flagrin. It binds to keratin fibers in epidermal cells. Plectin. It links vimentin to other vimentin fibers. Kinesin. It connects vimentin to tubulin. Plakoglobin, desmoplakin, desmoglin, and desmoculin. They bind to keratin filaments in epithelial cells. Thank you for watching. Please subscribe to this channel, and if you like the contents of this video, please like it. Now it's time to the quiz game. I have put the link to the quiz game in the description of this video. Download it for free and enjoy it. Until the next video, bye!